What's up everyone? In this video we're going to talk about problems like this and how to solve them. The first thing you need to notice here is that you have little f of x, and usually in problems like this you'll have a value of k that you don't know the answer for in the beginning, but the rest is pretty much the same. So essentially we need to first understand that you are going from little f to capital F. So we need to integrate the function, and when you go the other way around, so coming from capital F to little f, you need to differentiate the function. That's pretty much it. So the first step here is solving the k value. You are asked to find the expected value, or the mean, and then the variance. So let's start with the mean first. So the first thing you need to do here is find the value of k, and the main step here is making the function equal to 1. What I mean by this is you're going to use integral from 0 to 1. You get the k out of it because it's a constant. You don't know the value yet, but it's a constant, so it comes outside. And then inside you have the function, which is x squared. So x squared dx. And now this is the important part, because you'll find that in most manuals and exercises and all that, they skip a lot of steps. And you need to make sure you're doing each one correctly, so you understand. Doesn't matter if they complicate and throw the book at you, you know exactly what you're doing. So make it equal to 1. And this is important because the function varies between 0 and 1, and you are making it equal to the greatest value possible. So you have k comes outside because it's a constant. You have x squared because the function is x related, and then you make it equal to 1. The function varies between 0 and 1, essentially making it equal to the largest number possible, which is this one. So now it's a little bit of math here in regards to solving integrals. So essentially you have k outside, and then it's x to the third power divided by 3. And this varies between 0 and 1. So keep doing our math here. We'll find that it's k 1/3 because it's 1 minus the same function with a 0 there. So 1 minus 0 is 1. So you have 1/3. So k 1/3, that's what we have here, equals to 1. So just move the 3 to the other side and you'll find that its k is equal to 3. So this is the first step. Now that we have k equals 3, now we need to find the expected value. And the expected value is always a situation where you have, let's say, they ask you for the expected value of x. So what you do here to solve the function is have the function, so varies between 0 and 1, and it's x times the function of x dx. And since we already have the k value, so the k is a constant and the k comes outside and it's 3. So this is what we need to solve in order to find the expected value of x. If this was, just a note, if this was x, so they would ask you find the expected value of 1 over x. It's the exact same thing, but instead of having x here, you would have 1 divided by x. Just remind yourself of this, because most problems they will ask you for e of x, but if you have something like this, make sure you are solving it in regards to what they're asking you. So if it's e of x, you have x times the functions. If you have 1 over x, or whatever the parameter they're asking you to solve, it's that parameter times the function. Okay, let me just delete this part. Okay, so let's solve this problem then. So you start off by this. We already have the function there, so it's essentially the same thing, but you are multiplying with another x. So the function is x squared times x, so it's 3, and then x squared, so 0 1 x to the cube, because it's x that you have on top, times another x, so x cubed dx. And now you use the same method that we used before in order to solve this. So it's 3 times x squared. To get rid of the integral, it's to the 4th power divided by 4, so like this. And this part varies between 0 and 1. So essentially you will have 1 here to the 4th power divided by 4, so it's 1/4, minus 0 on top, so it's 0. So essentially you are left off with 3/4. So this is the expected value of this function. For the variance is solve as follows. The variance of x is e to the x squared minus ex squared. We already have this one, so it will be squared, but we're missing this one. And in order to solve this one, it's the exact same thing. And what we do here, essentially, doing some auxiliary calculations. So coming back to the same expression, so 0, 1, the constant comes outside. But instead of multiplying f of x with x, you multiply it with what they have inside. In this specific case, it's x squared. So x squared times the function dx, and you will find the value. So doing the same thing, so 3, 0, 1. The expression is x squared, and now you're timing it with x squared, so it's x to the 4th power dx. And you use the same exact method in order to solve this. So this is the same thing as having x to the 5th power divided by 5 from 0 to 1. And the same thing, so 1 goes inside, so 1 to the 5th divided by 5 times 3, and the other one is 0 because it's 0 is going on top, so it's 0. So 1 minus 0 is 1, so 3/5 is your answer. This is the first one. Now, in order to find the variance, remember that the expected value that we found was 3/4. And you are asked to use this value, but to square it. So what you do here in order to find the variance is as follows. The first number that we found, so it's 3/5 minus the second member, which is 3/4, but squared. So this is the same as 3 squared is 9, 9/16. So this is the same thing as having 3/5, 9/16. And now you can solve this problem by multiplying this to get it on top and multiplying this one to get it on top. So 16 times 3 is 48. And 5 times 9 is 45. We have a minus sign here, so it's 45. And this is all divided by, you multiply these two. 16 times 5 is 80. So just it's 48 minus 45 is 3. So your final answer is 3 divided by 80.